We're going to continue our work here in Chapter 3. We are at the top of page 163, and we're moving into a new topic now. And this topic is code repetition, and better known as loops. And this is a very important construct, and this is kind of interesting to do in JavaScript, frankly, because JavaScript allows for some flexibility that's kind of neat once you learn how it works. All right. The first type of loop that we're going to learn about is basically called a while loop, and you can see I should say the generic structure of how it works here at the top of the page, where we use the keyword while, and notice inside the parentheses it says expression, and that is where we're going to put some sort of a statement that allows us to, which will evaluate basically to true or false. So is 3 greater than 5, that type of thing. And then if the statement is true, the loop will execute. The number of statements inside the loop will depend on what it is you're trying to accomplish. And then the loop will continue until basically the condition changes where it's not true and it can't operate. Every time we go through a loop, it's called iteration. Did you ever hear the word reiterate? That's to do it again. That's kind of the tie-in there. So if you just say it once, you're iterating. If you're reiterating, you're doing it many times. The interesting thing also about working with a loop is often you need to have a counter, because that's one way you can break out of the loop. So if you know you need to do something a specified number of times, you would write something similar to this. And this is a very classic loop structure here. So you begin by actually setting up a variable prior to the loop starting, and you set it to a specific value. In this case, you're doing a counter. So they're setting count to 1. Now, we know since we set it to 1, if we're checking to see if count is less than or equal to 5, we know for sure it's going to run, right? So that every time we're going to go through this loop, it's going to document write, it's going to output whatever our count is, and then a line break. And then it does a count plus plus, and a count plus plus, remember, adds 1 to count. So we start with the value of count at 1. We come to the while loop, we check, is count less than 5? Yes. So we execute the statements of the loop. We output whatever count is currently, which is 1, and a line break, and then we increment. Count becomes 2. We go back up to the top, we check, is count less than or equal to 5? Yes, it is. So then we will do another output, and this time count is equal to 2, so we're going to output 2 on the screen, and then a line break. We add another, we get to 3. 3 is less than or equal to 5. We output 3 and a line break. 3 becomes 4. Back up to the top, 4 is less than or equal to 5. Yes. Outputs 4. It becomes 5. Is 5 less than or equal to 5? Yes. We do it again, so it outputs 5. We add 1, it becomes 6. Is 6 less than or equal to 5? No. We're done. Okay, so that's how a while loop works. So you have to have some way to either force the loop to run based on a condition, and then when you're running the loop, you have to have a way to change that condition to make sure you can get out. Because if I didn't have this statement in here, it would just go forever. And that's called an infinite loop, when you have a loop that doesn't stop. And that's generally not a desirable thing. Unless you're going to infinity and beyond. But basically that code that we just saw generates this output. So we output 1, 2, 3, 4, 5. We got up to 6, it wouldn't let it do it. And then we jumped out of the loop and it did this document write statement. All All right, if you want to practice that again, let's try to predict what this one will do. But notice there's a difference here. We're going to be counting down. Okay, so we're going to start at 10. Is 10 greater than 0? Absolutely. And then we're going to output 10. Then it becomes 9. Yep, that's true. 9. So it's going to go 10, 9, 8. Let's say we get all the way down to 1. 1 is greater than 0. We output 1. It becomes 0. Does it output anything else? No. Because 0 greater than 0 is false. All right, so this will output 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and then stop. And I'm sure on the next screen here, it's going to show us exactly that. So that's how while loop works with counting up and counting down. Now this is kind of fun because there's no reason why you have to count the ones. What this does is it multiplies by 2 each time. So when we start at 1, and we come in, yes, it will execute because 1 is less than or equal to 100, and it'll output 1, and then it's going to do what? What's the value going to be after this statement? 2. Because it takes whatever it currently is, multiplies it by 2, and puts it back into the variable. All right, so then it'll come back up. 2 is less than or equal to 100, outputs 2, and then 2 becomes 4. So what are all the subsequent values? 2, 4, 6, 8. It's going to be 1, 2, 4. I'm trying to see if you guys get it. 8, 16. Right, so what's the last number it's going to print? 64, because when it gets double of 64, it becomes 128 and it won't run. All right, and I'm sure that's our example there. Those are powers of 2, by the way. All right, so these are kind of fun to play with, especially if you've never been exposed to them before. And this is just one of a few different types of loop structures. But really, once you get the concept on one of them, then you're just doing these little tweaks and adjustments with different syntax, and you can do a lot with pretty much any loop structure. All right, now on this page here, what's kind of interesting, remember I was talking about an infinite loop before. Here's an example of one. So if we have a count set to 1, and we check, is count less than or equal to 10? True. And then it's going to output count. And then it does it again. Has count changed? No. It's still 1. How long is it going to run? Forever. Until you pull that cord out of the wall and make the computer stop. I had, very interestingly, a group I was teaching JavaScript to, and this is a good dozen years ago. And one guy is like, can I write an infinite loop that puts out pop-ups? So basically like infinite pop-ups. Yeah, and that's enough to crash a computer. At least back then it was. At this point, the browsers are smart enough to realize that you're doing it and stop the execution after a while. I don't know how many iterations before it goes, hey, wait a second. I know, don't get any ideas, you guys. All right, we're going to go back to Visual Studio now, and it says we're going to go back to our tt.js document, and it says below the variable declarations, enter the following code, and we're going to create a new function here. And frankly, what I'm going to do is I'm not going to copy all this and try to delete the line numbers. I'm just going to manually add this in. So let's go back to tt.js, And it probably recommended a spot for it below the variable declarations. Okay, that's where I am right now. You're going to create a new function, make a little blank space in there, and put in a closing curly bracket. All right. Our next step says within the command block, we're going to have a variable of I equals 0. So that's within the function. And then they're also going to have us set up the structure for a loop. So I can copy that part too. Notice here, instead of using the word count, they're using I. And one little tip I'm going to give you is very often when you see loops and they choose to use counter variables, I is a very common one. And the reason for that is I stands for index, and it also stems from mathematics too. So that's a real common one. Plus it's a whole lot shorter than count. It makes your code a little easier to read. And then we're going to go ahead and we're going to type in this little snippet of code, or paste in. And I want this all on one line. I don't want it split. And it says document get element by tag name th. Now if you look at our calendar HTML file, you'll notice that we have, very coincidentally, 7 THs, right, for days of the week. So can you kind of see where they're going with this? So what's going to happen here is we're going to, in a loop, pull the values out of our array for days of the week and put them into the table header. Now, the thing that we also have to do is we do need to put our little increment in there. And that's going to go after this spot here. And then you can, if you can envision this here, and what I'm going to do is actually, and this will help you to, I think, see it, is I'm going to move that variable declaration down here so it's just above the method, or excuse me, function. So we're going to set our counter variable I to 0, and then with I at 0 being less than 7, it will trigger. It will go to that first TH, position 0, because it's the I, right? And then for the HTML inside that tag, it's going to grab whatever is in days of the week position 0. Days of the week position 0 is Sunday. Then we're going to add 1 to I so it becomes 1. 1, of course, is less than 7, so it'll run again. And then it'll go to the second TH, which is TH position 1. And the HTML for that item is going to pull from days of the week position 1, which happens to be 0, 1. So you see the pattern? And then when it finally counts up to 7, it will not execute, and that's a good thing because position 7 would be over here, and there is no position 7. So we're using the loop to dynamically pull things out of the array and populate our HTML file. Now, the combination of using a loop with an array works really well. It also works well with like database entries and things, because often you'll have a list of things that over and over and over again. You're not going to want to write a piece of code, 7 times. This is only 7 times. What if you had a list of like 200? You going to write that line 200 times? You just write a loop that cycles through 200 times. That's that pattern that you need to start to recognize as you're doing this stuff. All right, so that's what we're doing here. I'm assuming we're probably pretty close to getting it to run. Oh, we got to put an event listener in there. It says below the function you just created. Well, they want us to put the comment in there too. You can put the comment in if you wish. Trying to copy that and it just won't let me. And it wants that down below. So it's going to be below this closing curly bracket. And then notice what it's doing. It's adding an event listener for load. In other words, when the page loads, it adds an event listener that triggers this function. So as soon as the page loads, it'll run this JavaScript and fill in the days of the week in all the THs. I'm doing a Control S to save so we don't lose the work. So save your changes and then reload calendar HTML. So we're going to go back to our browser now, wherever that happens to be. Get the right one. I'm going to close the console window and just kind of zoom back out. So I'm just going to hit a reload. It's pretty slick, right? And then if you right-click View Source, notice that it wrote the code for us. Now, if we could only write some code to do our own homework, right? Kind of like a self-driving car. All right. So that's an example of populating HTML elements using a loop. Now they're going to show you another loop structure here, and this one's called do while. And this is a little bit different because notice that we still have the keyword while in here, and we still have an expression that we're evaluating for true or false, but notice where it occurs. It occurs at the end of the statement. And we use the keyword do at the beginning. Now the major difference between this approach and the previous approach is this loop will run at least once no matter what you do, right? Because it'll cycle through, it'll do the statements, and then check to see if it should do it again. Okay? So a little bit different approach. Whereas with a regular while loop, it's possible that it never runs. So a difference here, still set up a counter. It'll go through, it'll output this code, it'll count up to 3, and then it'll say, well, count is less than 2, execute, but now it just became 3, so we only do it once. All right, and that's what they're trying to show you here. And then they're doing a comparison to a regular while loop that would in essence do the same thing, but you see like how the structure is a little different. So do while loops are useful when you need the code to run at least once no matter what. And then if you like check the syntax here again, notice they're using I now. I is set to 0. We're going to output the days of the week, the same code that we just did. Then we add 1 to I, so it becomes 1. Is 1 less than 7? Yes, we do it again. And it'll keep going until it gets up to the value of 7. So if you can imagine I is 6 and it outputs Saturday, counts up to 7 and goes, well, 7 is not less than 7, so it's false, and we're done. Slightly different logic, same effect. All right, so what they're going to have us do here is we're going to create a new function now We'll place it right here. And I'm going to create a closing curly brace for it right away. And then I'm going to grab these variables. One clearly is going to be a counter. And the other is just an empty string. Then we're going to set up the structure for our loop. And notice they don't have a while statement at the end. You guys notice that? And I'm not sure if that's a mistake or if they're going to, I'm assuming they're going to add it later. Okay, they are adding it later. And then this is kind of weird. Look at this code. And they want this inside the do while block. Okay, now what's that 8 dash all about?
Well, that's the idea of one of the tables, isn't it?
Bingo. Right. Remember we were looking at those weird ID numbers and how I casually mentioned it? Obviously with intent. But notice that all of the IDs for August begin with 08 dash and then the date. So what they're in essence doing here in this file is when they're going to loop through and they get element by ID, every time that ID starts with 08 dash, and then we're just going to concatenate to it whatever the current day is. Clever, right? All right, then we're going to send in this command. And this is basically going to pull back all the paragraphs. Notice it says paragraphs 0, so the first paragraph. And if you guys are curious what they're talking about here, then you should really go back to the document and take a look. I don't see any paragraphs, don't see any... Oh wait, okay, here we go. So you notice how each one of these table cells contains 2 paragraphs. So the first paragraph is position 0. All right, so you can probably anticipate that they're going to have maybe a position 1, or maybe they won't, and maybe not in this loop. That's a hint, by the way. So even though each one of these has 2 paragraphs inside of it, we are only going to be looking at the first paragraph inside of each, okay, which are currently empty. But we're going to be populating those. What are we going to be populating it with? Well, let me paste in this while closing statement here, and that's going to go right at the bottom. So it's going to find all the things with that ID. We already figured out what those are. We're going to find the first paragraph inside of those. And then the inner HTML for that paragraph is going to be what? The current count value. So we're going to start with 1. And while 1 is less than, or I is less than or equal to 31, so it's going to count up how high? 31, because there's an equal sign there. So it's going to basically go through all the different table data cells in the first paragraph position for each and print the numbers 1 through 31 in sequence through all the different table data cells. That's what it's doing. All right, so the next part here, this is what the completed code should look like. And then of course, we're gonna need to do a little bit of code. If you want to copy the comment in, that's up to you. But watch what this is going to do. We're setting up another function now that's going to sit independent. We need to get rid of these line numbers to make it work properly, because otherwise it shall complain. Save it. And then I'm assuming that we probably are going to change that event listener. It says in the last two lines of the TTJS file, replace both occurrences of add column headers with setup page so your code matches the following. So really all we're going to do here is we're going to switch that to setup page. Now conceptually what's happening here, when the page loads, it's going to trigger the function called setup page, which triggers two functions. See that? It's going to add the column headers, which adds the dates, or the names of the days of the week, excuse me, and then add calendar dates, which puts all the numbers for each one of the calendar dates in place. And you can probably anticipate what the third step's going to be, right? To put in the actual teams that you're playing. All right, so I'm going to do a Control-S to save once again, assuming he's going to have us run it now. Yep, he is. So we're going back to our page, and we're just going to do a refresh, and all the calendar dates are populated. And of course, if you right-click and view source, you can see, oh, where is it? Yeah, are they there? There's no errors. Quite a bit of stuff here, don't we? Well, we got something broken here. It's looking right on the page, and I guess I'm not too concerned about fixing it because it's working. But the output code is not quite right, because it should have filled these in, and it should have filled these in. All right, I'm not going to spend my time troubleshooting it though, because it works. That's a good rule of thumb, folks. If your stuff works, just leave it alone. All right, and what this is going to do now is it's going to lead us to the last type of loop structure called a for loop. Now, a for loop works in a little bit of a different way. In a for loop, when we create a counter variable, we do it directly inside the loop structure. We still have a condition that we check for true and false. That's in the middle. And then at the end, we have, okay, he's calling it a counter operation, and I think that's a good way to do it. Usually we increment or decrement, but in this case, he's just listing it generically, because you can do stuff other than just add or subtract. All right, so they show the process here, and I think probably the best way to do it is to take a look at something like this. So they have an array that they set up called brightest stars. You can see they have 5 stars in there. and then they set up the variable right inside the for loop, and then the statement is for true or false, while count less than brightest stars dot length. Now think about this for a second. What is the length of brightest stars? 1, 2, 3, 4, 5. Not index positions, length. The length is 5. Index positions are 0 through 4. Okay, so it says while count is less than 5 in essence. And then every time we loop through, we're going to add 1. So we start at 0. Is 0 less than 5? Yes. Do the statement. We're going to document right whatever is in position 0, which is serious. Very, very serious. Right? Then we're going to loop. Every time we loop, we're going to do what's in that third position, which is to increment. So count becomes 1. Is 1 less than 5? Yes. So we output Canopus. It becomes 2. 2 is Arcturus, I'm assuming is the pronunciation. It becomes 3. That becomes Rigel. It becomes 4. 4 is still less than 5. It becomes Vega. It becomes 5. 5 less than 5, false. That's your output. All right. Now, for the sake of example, I don't want to spend too much more time on this, but I will give you one thought before we actually move on to the exercise part of this. For loops, while loops, and do while loops can all, in essence, accomplish exactly the same task. It's just the syntax is slightly different. So conceivably, you can achieve the same effect with any loop structure. What I've seen, from programming for many years is that programmers who tend to get more experienced will lean towards using for loops in general. That doesn't mean it's always the best kind of loop to use. There's some advantages to using the other loop structures from logical standpoints, but you can accomplish basically the same thing. All right, so let's go back to our JavaScript file. We're going to add a new function called addGameInfo. Let's put that above setup page. Closing curly bracket. Let's add a variable for paragraphs. So, that approach is going to be similar to what we just did. We're going to set up our loop structure. Notice the logic for the loop. Our counter is going to start at 0, and while that counter is less than 31, it will run, and then each time it will increment by 1. Okay, next statement. We're adding in a variable for the date. That goes inside the loop. And the reason we're doing date I plus 1 is because we start at 0, but the first date is 1. Right? So if we're going to put the stuff in the right date, we always have to add 1 to make sure it's in the right position. And that's one of the things when you're first working with loops, if you've never done this before, that's one of those things that you'll pick up on as a technique. Just does not want to let me select it. Oh, there we go. Once again, we're putting in that same sort of variable thing. This is exactly what we did before, but instead of I, it's going to be date. So the date's going to be whatever our array position is plus 1. So we're going to start at 1. Next, we're going to do the output part of it, just like we did up above here. And what are we going to output? Well, first of all, we're going to find it. And then you can anticipate the next line is just going to be like the one we did above. But this time it's going to pull from the opponent's array. So what it's going to do is one by one, it's going to go through this list, and it's going to take lightning and put it on a date, combines, put it on a date. So hopefully that's pretty clear. This is what your completed function should look like, just in case you mistyped. And then inside that setup page function, we're going to add one line. You know, honestly, it's probably easier to just type it because Visual Studio is intelligent. You see, as soon as I start adding add, it just does it automatically. Put our parentheses and our semicolon in there. So now when the page loads, it runs this function, which runs all 3 functions and populates the table. And we have to assume that's the last step, and it is. So go ahead. Go back to the browser. Well, make sure your work is saved first, I suppose. Yep, it's saved. And then do a refresh, and then all the opponents are dropped into the calendar as well. It's a pretty cool example.